there, welcome to today's video on the intermediate value theorem. Now, first I want to state the intermediate value theorem so it's accessible right there to use it as we're going through the example. So the intermediate value theorem says that suppose you have a function f of x that is continuous on a closed interval bracket a comma b bracket, meaning that the endpoints are included. Let capital V be a value between f of a and f of b. Then there is at least one c between the endpoints of the interval a and b such that f of c will equal v. So one of the things that's really important for you to remember here is that value v is an output. It's an output between the outputs of the function at the left endpoint and the right endpoint. And your value c is an input. And it's an input that has to be between the endpoints of your interval a to b. So here's our example. Let f of x equal x squared minus 7x on the closed interval -3 to 1. So f of x equaling x squared minus 7x, well, that's a polynomial, and polynomials are continuous over the whole real number line. So definitely it's continuous over the closed interval. So we have that aspect of the intermediate value theorem met. Now on the closed interval -3 to 1, so squared brackets, it's a closed interval, so I also have our closed interval. I still need to see the rest of the question and see if we have the rest of the intermediate value theorem met. So it says, is there a solution to f of x equaling 18? So our output is 18. That's corresponding to this v value in the interval between -3 and 1. Same numbers that we had in the closed interval up here. And if so, find that value of c in the interval such that f of c is equal to our 18. Well, the last part of the intermediate value theorem that we have to verify to see if we are guaranteed a solution is that this value v, our 18, has to be between f of a and f of b. So we need to calculate those. So here, our function f of x is x squared minus 7x. So f of something is equal to something squared minus 7 times something. And we want to start with that something being -3, the left endpoint of the interval. And when we go through and calculate that, we get that f of -3 is 9 plus 21, or 30. Now we want to calculate our f of 1. So again, we'll do f of something is equal to the something squared minus 7 times something. We are going to take out the x's and put in our something, which is our value of 1. So f of 1 is equal to 1 squared minus 7 times 1. And we get for this that f of 1 is 1 minus 7 is -6. And remember, our value v has to be between those. And 18 is between 30 and -6. So yes, we are guaranteed at least one c, one value in the interval that is a solution to f of x is equal to 18. Next up, we want to find that value because we've verified that we're guaranteed one. So we want to follow what this says, such that f of c is equal to v. And remember, our v is 18. And our function is f of x is equal to x squared minus 7x. F of C means just take out the x's and put in c's instead. So instead of writing x squared minus 7x, I'm going to write c squared minus 7c is equal to our output of 18. Now that's quadratic in C. So to solve a quadratic equation, we want to have a 0 on the right-hand side. We have c squared minus 7c minus 18 is equal to 0. We look to see if that's factorable, and if not, we could use the quadratic formula, but this does factor. The factors of negative 18 that add to get negative 7 are negative 9 and positive 2. So we have c minus 9 times c plus 2 is our factorization. That gives us c minus 9 is equal to 0, or c plus 2 is equal to 0. Solving for c, I get c is equal to 9, or c is equal to negative 2. But remember, the c's that we are interested in are in our interval. Our c has to be in the interval between my negative 3 and 1. And when I compare those, 9 is not in that span of values, but negative 2 is. So yes, we are guaranteed a solution to f of c is equal to 18, and our solution is actually that c is equal to negative 2. Well, I hope that's been helpful in being able to get a little bit of a better handle on the intermediate value theorem. See you next time.